for either circle. Here we've got a circle. It's centered at the origin, so 0, 0. And I've got a position P on the circle that's defined as x, y. So that's just a position in the Cartesian plane. So we can obviously see a triangle can be easily calculated here, where we've gone a base of x, a height of y, and the hypotenuse would be the radius of the circle as r. So straight away we can come up with that r squared is equal to x squared plus y squared. Mostly when we're dealing with functions, we want to have y as the subject on the left-hand side. So let's just swap the left and the right. Let's take x squared from both sides. And now to strip it down to being just y, let's take the square root of both sides. Now that will produce both a positive and negative version of the square root of r squared take x squared. Now y equaling positive square root of r squared take x squared will produce the upper part of the circle. Y equaling negative square root of r squared take x squared will produce the bottom part. If the positive and negative isn't given to us, then we must assume that we're dealing with the positive part, so therefore the upper half of the circle. This idea is shown here. Now, in the general situation of a circle that is centered at h, k, with a radius of r, then we say we have x minus h squared plus y minus k squared equals r squared. That will be a full circle of radius r, and it will be centered at h and k. X equaling h, y equaling k. First problem, sketch the graphs of the following circles, state the domain and range of each. So we've got x squared plus y take 3 squared plus 1. To begin with, a midpoint. So x is 0. I'll make this equal to 0 and solve for x to get y equaling 3. So it's at 0, 3 will be centered. R is going to be the square root of 1, which is just 1. So you can see that I've got my circle here, and there it all is given. Now I was supposed to state my domain and range on this, so my domain would be from -1 to +1, including those values, so I'll be using square brackets. And my y values are from 2 to 4, and again using square brackets, because I'm including 4, I'm including 2. For b, you can see I've got x plus 3 squared plus y plus 2 squared equaling 25. So for b, what I'm looking at is first of all to work out where the midpoint is. So I'm going to have x equaling -3, y equaling -2, and that's shown here. My radius is going to be the square root of 25, so that's going to be 5. So from there, now what I can do straight away is work out as low as I'm going to go and as high as I'm going to go, and that's really important for my domain and range. So as high as I'm going to go is going to be -2 plus 5 to give me to 3. As low as I'm going to go from -2 take away 5, which is going to be -7. As far as x is concerned, on the left-hand side, my furthest point is going to be -3 take away 5 to give me -8. Just there. And as high as I'm going to go is going to be, or sorry, as far to the right as I'm going to go is going to be -3 plus 5 to give me to 2. So that helps me calculate my domain and range. Now, as far as the intercepts are concerned, then what I need to do is, the easiest way is to deal with the CAS here. So with my CAS, I simply put in the expression and I'm solving for y. and that will produce two versions, positive or negative, of that format that we've got there. And then I can define them separately. So I define f of x, and that will be the upper half, and then I'll define g of x with that negative out the front, and that will be the lower half. To get my x-intercepts, I just simply solve f of x equaling 0 for x, and that will produce here and here. Please note that if you did the lower half, which is from there all the way around, you won't have any x-intercepts because the lower half of the circle, that is g of x, does not cut through the x-axis, so that is sensible. To evaluate the y-intercepts, I simply evaluate f of 0 to get 2 and g of 0 to get negative 6. And that's shown there. Problem 2. Find the centre and radius of a circle with the equation x squared plus y squared equals 6x plus 8y plus 24. Now that's not in the standard format that we're used to. If it was written as A or B, this would be a really easy question. So what we're going to do is manipulate this equation so it's in this kind of format, and then we can start looking at sketching the circle. Okay, so what I'm going to do here is look at the x's and the y's and try and group them together, and then having a number on the right hand side which will represent the radius of the circle. So I'm going to have x squared, I'm going to subtract 6x from it. I'm going to have y squared, and I'm going to subtract 8y, and then that will leave me with just a 24. So I've moved 6x and 8y across the left hand side and positioned them next to the x squared and y squared. What I want to do now is use the completing the square method twice to create two perfect squares. So that's going to be the first perfect square, and this is the second perfect square. When I have perfect squares, I can factorize them. And the whole idea behind being able to factorize them is to get it into this format. So let's look at the x squared takes 6x. What do I need to add to that to create a perfect square? So here in green, you can see I've got my little grid. The coefficient of x is negative 6. I halve it and square it, so it's 9. So I've got x squared takes 6x plus 9. And if I'm doing that to the left, I have to also add 9 to the right. Okay. Now let's look at the y's. I've got y squared take 8y. I want to add a number to it to create a perfect square. You can see it's 16. How did I get there? Coefficient of y is negative 8. I halve it and then square it to get the positive 16. So I'm adding 16 to the left. I have to also add 16 to the right. So what do I have now? I've got a perfect square here, and I've got another perfect square there. Adding all these together gives me 49. And so now, with this perfect square, that can be factorized to become x take away 3 squared. And this one can become y take away 4 squared equaling 49. So what I know is that the radius of this circle is going to be the square root of 49, so 7. And it's going to be centered at x equaling 3, y equaling 4. In problem 3 here, it's a little bit in reverse to what we usually do. We're told that the circle is centered at 2, 3, and it's got a radius of 5. We've got to sketch it. Now obviously, you could easily just go, okay, let's locate 2, 3 on the Cartesian plane. Let's grab ourselves a compass and set the radius to being 5, and then draw your circle. But when we're drawing our sketches, we need to provide exact values for the x and y intercepts. So the only way of doing that is to take this information, convert it to the standard equation, and then use algebra to find those exact locations for the intercepts. Let's look at this by hand. X-intercept, y is equal to 0. So I take the rule, So to go from here to there, Well, obviously it's centered at 2, 3, so it's x minus 2 squared plus y minus 3 squared. The radius is 5, so on the right-hand side I've got 5 squared, which is 25. But let's look at the x-intercept now. We have y equaling 0, so I take the standard equation, substitute y equaling 0, and I get this. I take away 9 from both sides, and now I take the square root of both sides. So the square root of x minus 2 squared just becomes x minus 2, and the square root of positive 16 is both positive 4 and negative 4. I now add 2 to both sides and end up with x-intercepts of 6 or negative 2. Same approach is used for the y-intercept, so this time x is equal to 0, so I sub in x equaling 0. I take 4 from both sides. I take the square root of both sides, giving me 2 options on the right, so positive square root of 21 or negative square root of 21. And I end up with y equaling 3 plus square root of 21 or 3 minus the square root of 21. Notice that these are the decimal approximate answers, and I should never write those down on my graph. So I draw them in. Centered at 2, 3, there's my circle. Please note that I've incorrectly put the intercepts in. So in this position, I should have x equaling negative 2, and over here I should have x equaling 6. For my y-intercepts, I should have 3 minus the square root of 21 and 3 plus the square root of 21. So make sure that you change that on your graph. If we now think of the domain and range for this graph, I want to think of the extreme values on the left, right, bottom and up. So from 2 on 3, remember the radius is 5 here. So if x is equal to 2 and the radius is 5, the furthest point on the left-hand side is going to be 2 take away 5, which is negative 3. On the right-hand side, I'm going to have 2 plus 5, which is 7. So my domain is going to go from negative 3 to positive 7. And that will be with square brackets to show that we're including those points. For my range, the middle of the circle has a y value of 3. The radius is 5. So the highest value I'm going to achieve is going to be 3 plus 5, which is 8. And the lowest value I'm going to achieve is 3 minus 5, which is negative 2. So my range is from negative 2 to 8, again with square brackets to show that we're including it. Now, how do we go about doing this using our CAS? There's a few steps. So I'm going to begin at the very top here. I take the standard equation here, and I've got menu, algebra, solve, put in the standard equation, we're solving for y. What can be seen next is that that produces 2 solutions, and that's not a surprise. We know that one of the solutions is going to be the upper part of the circle, and the other is going to be the bottom. This one involves the negative, so over here where it's all positive, that's going to be the upper part of the circle, and that's what I'm going to start with. So I'm going to put this in here and define it as f of x. So f of x is equal to this, which will be the upper part of the circle. The bottom part of the circle I'm going to define as g of x, and that's going to be still positive 3, but I'm going to take the negative of the square root symbol. And that's there. Now, to work out the highest and lowest values that we can have for our circle, I'm going to use f of 2 and g of 2. And the reason being is that the value of x at the center of the circle is 2. So f of 2 will give us the highest value, and g of 2 will give us the lowest value. So if we go and take a look here, substitute 2 into f of x. Remember, f of x gives us the top part. So f of 2 produces an 8, so 2, 8 is that position. And then g of 2, remember g of x is the bottom part of the circle. G of 2 gives us our other solution, which is negative 2. So this position down here is 2, negative 2. Other points of interest for us are the y-intercepts. So along the y-axis, remember, the value of x is 0. So f of 0 is 3 plus the square root of 21. And g of 0 is 3 minus the square root of 21. So in this position, remember it's currently drawn incorrectly, is 3 plus the square root of 21. And this is 3 minus the square root of 21. And going further, to look at the x-intercepts, let's take the top part of the circle, make it equal to 0 and solve for x, and we get a result of of false. And this makes sense because that's the top half here, and at no stage will the top half cut through the x-axis, so it makes sense. G of x, the bottom one, will cut through the axes twice, at -2 and +6, and that's shown here. If we want to sketch this graph, it becomes quite easy because we're broken into the top half, f of x, and the bottom half, g of x. So if I go to my graph, then you can see I've put in f of x, and that draws what we've got in blue. And then if I hit tab, I can put in g of x, and that's already been done there in red, as you can see. So I can turn these on and off, and I'll turn it back on. You can see there we've got our complete circle. Hopefully all of that makes sense with you.